In this lecture, we're going to see a few examples of enhancements and techniques used with statistical forward planning methods when dealing with complex games. In particular, we're going to see three different types of techniques: pruning techniques, methods to tackle imperfect information games, and portfolio search. So let's start with pruning techniques for tree search. We have seen how Minimax was improved with pruning techniques in order to beat alpha-beta search. Pruning suboptimal moves is highly beneficial for tree search, and by extension, the same applies for Monte Carlo tree search. By default, MCTS learns to focus on the actions that are more promising and ignore those that are less so. However, this is done at the cost of iterations of the algorithm. If we could provide a way to automatically prune nodes quickly, we'd be helping the algorithm considerably. Alpha-beta was quite general in the sense that it didn't need to use knowledge about the game in order to do the pruning. Here we're going to show some methods that use game-dependent knowledge and some others that don't. We can also make an alternative categorization of pruning attending to how strict the operation is. In some cases, we'll prune a branch of the tree to never explore it again. This is called hard pruning, and an example of this is alpha-beta pruning that we have already seen. However, in some cases, we can do a soft type of pruning, which labels some options as pruned for certain iterations, but progressively, those branches become available again. Progressive unpruning, which we will see later on, is an example of this type of pruning. There are pros and cons for both approaches. Hard pruning is more strict, which makes search more efficient. However, if the decision to prune is wrong, we might have lost the best action to apply forever. Soft pruning, on the other hand, attempts to correct these possible mistakes at the expense of some computational cost.